So let's try to solve some problems from 14.3 now. So you guys should try to solve, just try to solve number 1, okay? Don't try to do anything from number 2, you won't be able to do that. So let me solve a couple of problems from number 1, and you guys can do the rest. So I'll start with the first one, which is in the range of 1 and 3. We're integrating half x squared dx. Okay, so that doesn't look too complicated. We have half times x 2 plus 1 divided by 2 plus 1. The range for this is 1 and 3, plus c as well. So what do we get? X to the power 3 divided by 6, 3 c. Effectively what we get is 3 cubed by 6 plus c minus cubed by 6 minus c. So c and c cancels out. And what we are left with is 27 minus 1. So 26 divided by 6 or 13 by 3. That's the answer. And if let's try and solve something that's a bit complicating. Let's do f. 1f. I think that it looks like the most difficult problem here. The range of 4 and 2, is it? Can't really read. The print isn't good in my book. So we have x squared 1 by 3x cubed. So now there are two ways of solving this. One would be to just simplify this. Since the printing in my book isn't very clear, I'm not sure what the powers are. So let me just ignore them for now. Let's focus on the integration first. So one way of solving this would be to just multiply this. So we are left with 1 by 3x to the power 5 plus x squared. And we differentiate this entire thing. And so that is going to give us 1 by 3 x to the power 6 divided by 6 multiplied plus x cubed power cube plus c. So what we get is x to the power 6 by 18 plus x cubed by 3 plus c. And then of course we will have the range, whatever we have here and here, and you calculate that. It's just numbers. Come up with your own numbers and do that. The second way of solving this, so this is method 1. Method B would be x squared 1 by 3 x cubed plus 1. So what I can do, in this case I don't have to, so let's suppose if I have this to the power 50. So in that case I can no longer simplify the way I did in this step, right? I can no longer simplify. So what would I do in that case? What I would do is I would assume u is equal to 1 by 3 x cubed plus 1. In that case, if I differentiated u with respect to x, what I will get is x squared dx. Oh, no, sorry, no dx here. So what I know is that dx is equal to du by x squared, right? And now I can start replacing things. So integrating x squared times 1 by 3 x cubed plus 1 is u. And dx is basically du by x squared. So x squared cancels out. And I am left with u du, which integrated gives me u squared by 2 plus c. Now, of course, I know that u is, what was u? 1 by 3 x cubed plus 1, this whole thing square by 2 plus c. And okay, let me just simplify this and show you guys something. You can leave your answer like this if you want to. Unless, of course, you have range in which you have to plug the values in. But let's simplify this function a little bit and see what we get. So we have half times 1 by 3 x cubed plus 1 square plus c. So if I simplify this, I get 1 by 9 x to the power 6 plus 2 by 3 x to the power x cubed plus 1 plus c. And so this becomes 1 by 18 to the power 6 plus 2 by 6, or basically 1 by 3 x cubed plus half plus c. Now c is a constant, right? We do not know how much it is. It can be 5, it can be 10, it can be a million. And so this is a constant as well. So what we can do is just lump them together. And so what you see is that our answer here in method 1 and our answer here in the second method is exactly the same. So I just wanted to illustrate to you guys that whichever method we use, we'll get the same answer. Okay. So often A and F from number 1. So why don't you guys give it a go? Try and do the other 4. And of course, if you have any problems, you can always come to me. What else is there? Well, you don't try to do 3, 4, and 5. We're not going to go into that. So that's the end of 14.3. Let's move on to 14.4 now.